This video follows on from the previous one. We're looking at a means of adjusting total station survey data for control to fit or to be oriented towards OS national grid coordinates that have been established using a GNSS method. I've got those coordinates already imported into this project, and now I'm going to bring in the total station data once more. Again, I need to merge the point coordinate values onto the same point position. And again, as per the previous video, I'm going to go in and delete the local grid coordinate with 100 easting, 200 northing. And I also don't require the azimuth on this example as well. So I'm going to recompute. Zoom extents, and if I check my flags, it should be this 23mm misclosure, if you like, or discrepancy in position between the GNSS based coordinate for L2 and the other information that's going around this loop and around that comes back to L2. This method will be based on fixing all of the GNSS coordinates in the solution to position and orient the total station survey data. Just going to adjust traverse. The settings are as per the previous video. So if we look here, default standard errors, imported files, project settings for our centering errors, and using all of the results from the mean angle computations for the rounds of angles rather than the individual measurements. So L2 is fixed, origin point here if you like, in 2D and elevation. Delete that azimuth. Won't be needing that. So this is our starting point. So it's a minimally constrained adjustment around L2. It's just warning me that I still have flags before I start adjusting, which I've checked and I'm okay with those. So same as last time, I'm just going to increase, in this case, change and decrease the anticipated error in the network. So we're scaling down the amount of anticipated error. For the HAs, the distances getting closer to 1 now, and the vertical angles as well. So nothing really different here from the last attempt at this using the coordinate and azimuth. Where it's going to diverge is what we constrain next. So instead of constraining an azimuth between a point pair, I'm going to constrain the other GNSS derived coordinates in 2D. As stated previously, this processing isn't overly concerned with the elevations, as we'll be taking those from a digital level survey. This being GNSS data, it won't be of the same level of precision as the total station data in all probability. So I'm going to put in some standard error estimates for the quality of this data based on the GNSS processing and network adjustment that was completed earlier. So I'm going to enter the elevation, although the elevation, as I say, won't be required for this one. So I'm going to say that there's a 3mm, approximately 3mm standard error in terms of the quality of the horizontal component of these coordinates and 4mm in the vertical. We'll see how we go with that. These would be reasonable values in most circumstances for shorter baselines that have been processed. So these are held in 2D, and the main anchor point, if you like, L2, is held in 2D and elevation. So now I will adjust. Okay, chi-squared test has still passed. Let's look at the network adjustment report. So here we have our control coordinate comparison, so the adjusted position based on the total station observations versus the original GNSS position. So approximately 4 mil difference at L1 in easting and about 9 mil in northing, and the delta elevations are shown here. So we have our error estimates in the eastings and the northings, again, nice low values here. The error ellipses look pretty consistent as well, and there's no outliers, nothing is flagged in red based on the standardized residuals and the tau criteria as shown in the histogram bar down here. So we've successfully adjusted the total station survey based on a least squares algorithm to best fit to the GNSS based control. It's not an exact fit because we've given some wriggle room in the adjustment by allowing this standard error value to come into play here. So it's not saying the standard error is 0, there is some standard error associated with the GNSS data. So we've got a best fit orientation and fit in easting and northing to the GNSS control, and L2 is fixed in easting, northing and elevation. And again, if you wish to inquire deeper into the point coordinate origin of any of the information in here, just select it in the list and open a point derivation report. So we have our adjusted value at the top, and then any data that will also position L6, the associated coordinate, is shown as a delta here as well. So that completes this video tutorial on adjusting a set of total station control observations via traverse survey with multiple rounds observed to GNSS derived control by holding one control point fixed in position and best fit orientation and position based on the other 3 coordinates that are available for this project.